Hi children, in the last class we were discussing types of reactions and we did combination reactions. Remember what combination reactions are? They are the reactions in which a single compound is formed by the joining of two or more substances. The substances can be elements or compounds. These substances join to give a single compound. Now, today we are going to learn decomposition reactions. Decomposition reactions are quite the opposite of combination reactions. Here, a single compound is broken down into two or more simpler compounds or elements. Understand, a decomposition reaction is one in which a single compound is broken down or it is decomposing into two or more simpler compounds. This requires some sort of energy. Depending upon the type of energy that is used for decomposing, decomposition reactions can be generally divided into three: photolytic, thermal and electrolytic. What do you mean by photolytic decomposition? Photolytic decomposition is a decomposition reaction which happens in the presence of light. Photo means light. Okay, so this type of reaction takes place only in the presence of light. The two common examples are decomposition of silver chloride and silver bromide. Now let's generally represent a decomposition reaction as A splitting up into B plus C. For this to happen, some sort of energy has to be provided. This energy can be either light energy, then it becomes photolytic decomposition, or it can be heat energy, then it becomes thermal decomposition, or it can be electricity or electric energy, and then that decomposition is called electrolytic decomposition. So decomposition reactions are of three types: photolytic, thermal and electrolytic. Generally, it can be represented as A breaking down or decomposing to give B and C, or B plus C plus D. It can be more also. Now let's first discuss photolytic decomposition. The presence of light of, or you write light or H nu. This chlorine is a gas, it is liberated. Two chlorine atoms, so I have put a 2 here and I can put a 2 here, so it is balanced now. Silver chloride is a white powder. You take some silver chloride in a watch glass, leave it near sunlight. After some time, you can see a grey powder left behind, which is silver, and the chlorine gases evolved. Same happens when you keep silver bromide in the presence of light. You get silver and bromine gas, which is liberated. Again 2, so I put a 2 here and I put a 2 here, so it is balanced. Again you get a grey powder left in the watch glass. These are two reactions which involves breaking up of a compound using light, or decomposition using light. The experiment is, you take 2 grams of silver chloride in a watch glass and leave it near the window where there is enough sunlight. After a few hours, you can see that the silver chloride, which was white in color, has turned to grey, which is just silver, and the chlorine gas has evolved or been liberated. So this is a decomposition reaction. Again, silver bromide also decomposes to give silver and bromine gas. This reaction is very important in black and white photography. Let's move on to thermal decomposition. Thermal means heat is involved. So these type of decomposition reactions require heat. When you heat the substance, you get the products, or you get the decomposed products. There are few examples to learn under thermal decomposition. In the first one, you take 2 grams of ferrous sulfate crystals in a boiling tube and heat it. When you heat the ferrous sulfate crystals, at first the ferrous sulfate crystals loses its water of crystallization and it forms FeSO4. Again, on continuous heating, FeSO4 turns to Fe2O3 and sulfur dioxide and sulfur trioxide. Fe2O3 is ferric oxide. It is reddish brown color. So you get a reddish brown crystal in the test tube, and there is evolution of sulfur dioxide and sulfur trioxide. These gases have the smell of burnt mastics. So you can identify the gas. Also the crystal formed has a different color from the crystal that you have taken. Ferrous sulfate 7H2O, which is taken in the boiling tube initially, is green in color. On slight heating, it loses its water of crystallization and you get a white ferrous sulfate crystal, FeSO4. This on continuous heating changes to Fe2O3, which is reddish brown in color. So this is the complete decomposition of ferrous sulfate 7H2O. Let's see the reaction. Fe2SO4 7H2O, which is green in color, on heating changes to FeSO4, which is white in color. Then FeSO4 on further heating converts to Fe2O3, which is reddish brown. And sulfur dioxide and sulfur trioxide, these are gases which are liberated. Another example of thermal decomposition is decomposition of calcium carbonate. In the presence of heat, limestone or calcium carbonate changes to quicklime or calcium oxide. Quicklime is also called lime. It is used in the manufacture of cement. It is a very important point. It is used in the manufacture of cement. And carbon dioxide is also formed, which is liberated. The third example of thermal decomposition is the heating of lead nitrate. Lead nitrate, 2 grams of it is taken in a boiling tube and it is heated. On heating, it decomposes to give lead oxide, nitrogen dioxide and oxygen. You get brown fumes of nitrogen dioxide. This is the observation. Okay, so you take 2 grams of lead nitrate in a boiling tube. On heating, you can see brown gas evolving. This is nitrogen dioxide, which is formed by the decomposition of lead nitrate into lead oxide, nitrogen dioxide and oxygen. Lead nitrate gets converted to lead oxide, nitrogen dioxide, which is a brown gas, and oxygen. This is a brown gas. This is the observation that you have to look for in the boiling tube. Nitrogen dioxide and oxygen is given out. Now, the third type of decomposition reaction that you have to learn is electrolytic decomposition. It takes place with the help of electricity or electric energy. You have to learn the electrolysis of water to give H2 and O2. Water decomposes to H2 gas and O2 gas with the help of electricity. This is called electrolysis of water. For this, you need a plastic mug. Drill 2 holes at the bottom of the plastic mug. Then attach 2 rubber stoppers. Through these holes, insert carbon electrodes. And then you attach these electrodes to the 6-volt battery. The graphite rod which you connect to the negative side becomes the cathode, and the one that you connect to the positive side of the battery becomes the anode. Fill the mug with water up to the graphites or the carbon electrodes. Add some dilute hydrochloric acid or dilute sulfuric acid to the water. Water, as it is a bad conductor of electricity. So in order to increase the presence of ions in it, H plus and OH minus ions in it, we add acid, dilute acids. Take 2 test tubes with water and invert them on each electrode. Now switch the battery on and wait for the reaction to happen. After a while, you can see gases evolving. There will be bubbles on the electrodes. You can see bubbles formed inside the test tube which is placed on the electrodes. The amount of bubbles present on the cathode side will be much more than on the anode side. This is because more hydrogen gas will be produced compared to the oxygen gas which is produced at the anode. After the gases have formed, you can do testing for the gases. Hydrogen gas will burn with a pop sound and the oxygen will increase the intensity of the flame. So from this observation you can have the inference that the gas produced at the cathode is hydrogen, the gas produced at the anode is oxygen. So this is the electrolysis of water to give H2 and O2. So this is the plastic mug. You drill 2 holes here and you attach rubber stoppers. Through the holes, insert 2 carbon electrodes. These electrodes are connected to a battery. Now fill the plastic mug with water so that both the electrodes are immersed. This is water. Add dilute H2SO4 so that you have more concentration of H plus ions. Now invert 2 test tubes with water on each of the electrodes and switch the battery on and wait for the reaction to happen. After a while, you can see bubbles formed at both the electrodes. Water is displaced due to the formation of bubbles. H2O decomposing to H plus and O2. 2, it is balanced. It happens in the presence of electricity. Okay, so if I divide both the sides by 2, I get 2 plus half O2. That is, for every molecule of water, 1 molecule of water, I get 1 molecule of hydrogen and half molecule of oxygen, that is 1 atom. So we can expect double the number of hydrogen at the cathode when compared to the gases evolved at the anode, that is oxygen at the anode.